Trigonometry made simple. This module here, trigonometry, is a very important subject and the principles are widely applied in many other subjects. Therefore, the importance of understanding it cannot be understated, and if you can understand it, you'll be able to apply its principles in other related subjects. Now, this subject is sometimes considered quite complex and understanding it can be considered difficult. However, I feel that if I can try and explain it simply to you, and if you follow a number of simple rules in a logical manner, it'll make it easier for you. Now, what I'm arguing is there's 5 real steps to follow when looking at trigonometry made simple. And I've got a 5-step guide that I think will help you. Hopefully it will help you. You might have your own model, but this is the model that will help you. This is the acronym. Canadian swans prefer small insects. That's it, Canadian swans. What's the C? The first thing you're going to do, and I'm going to go through all these, is you convert it into a series of triangles. You need to convert whatever shape you've got, your polygon, whatever shape it is, into a series of right-angled triangles so you can use the principles later on. That's the first thing you're going to do. The second thing you do, S, is you get the sum of all angles. Yeah, I'm going to come on to this. The sum of all angles helps you fill in other angles that are unknown. Then we're going to go through P, which is Pythagoras' theory. Then we're going to use the principle called SOHCAHTOA. SOHCAHTOA. I'm going to go through it later and explain it to you. And the I is inverse SOHCAHTOA. In other words, it's a different principle when you don't know certain things. So that's the thing. First of all, you're going to convert to triangles. Then you're going to use the sum of all the angles, Pythagoras' theory, SOHCAHTOA, and inverse SOHCAHTOA. You try and apply those 5 principles to trigonometry problems and it should help you. Let's go through one. What do you mean by step 1, converting to triangles? Well, firstly, you convert the polygon into a number of right-angled triangles. And again, this will help you then use the other 4 principles to solve the problem. Let's do an example. There's a shape here. Convert this into right-angled triangle. How do you do it? Well, you draw a line there, don't you? Simple as that. You draw a line there. You've got 2 right-angled triangles, which you can apply the principles later on. Convert that into right-angled triangles. What do you do? Again, simple again. One line will make 2 right-angled triangles that you can use the principles later on. Now, convert this shape into right-angled triangles. Well, now, how many does this have to be converted into? Well, as you can see here, this converts into 6 right-angled triangles. Yeah, 6 right-angled triangles that will convert into. But again, it will help you later on. Once you've converted into right-angled triangles, you can use the principles of all these, the other 4 steps to solve trigonometric problems. Convert this shape into right-angled triangles. How many we're going to get? Well, as you can see here, it converts into 1, 2, 3, 4, 5, 6 right-angled triangles. You've got to convert into right-angled triangles with the principles that I'm going to go through on this course. So that's step 1, convert to right-angled triangles. Let's move on to step 2. And this is the sum of all angles. That's the thing. Now, this is the rule to determine the sum of all angles in a polygon. This is the formula here. The sum of all angles in a polygon equals 180 times n minus 2, and n is the number of sides. So the sum of all the angles, the degrees, is n minus 2. Let's do some angles. Determine the sum of all angles in that polygon. Well, it's a triangle. It's got 3 sides, so 180 times 3 minus 2 is 180 times 1, 180 degrees. So the sum of any triangle, always add up, of all the angles, adds up to 180. All 180. Determine the sum of all angles of this polygon. Again, triangle, 180 degrees. Now, knowing this rule is very important because it allows you to immediately determine, if you've got 2 angles, you can immediately determine what the 3rd angle is. For example, look at this there. What is the angle there? What's the angle there? Well, you know straight away it's got 3 sides, so it's 180 degrees. 80 plus 70 is 150. That is 30 degrees. We know that's 30 degrees. It's the unknown angle. Determine the unknown angle there. Well, if I've got 55 there and 55 there, that's 110. That must be 70 degrees. It must be 70 degrees. This allows you to fill in unknowns if you know 2 of them. If you know 2 of them, you can always put in the 3rd because it always adds up to 180. So that covers triangles, 180 degrees rule. Let's move on to a 4-sided shape then. What's here? As you can see, apply the rule. The rule, how many degrees in total? Well, the rule is polygon 180 times n minus 2. Well, it's 180 times 4 minus 2, it's 180 times 360 degrees. So a square, all the angles of any square or four-sided shape polygon will add up to 360 degrees. So let's do an example. What about this one here? We know 3 of the angles, don't we? Add them all up, add all those 3 angles up, you get 290 degrees. Well, 360 minus 290 is 70 degrees. The angle there missing is 70 degrees. And this rule applies to all polygons. What about this shape here then? Well, this shape's got 5 sides. Apply the rule of polygons. 180 times n minus 2 equals 180 times 5 minus 2, 180 times 3 is 540 degrees. Well, we know it's 540 degrees. What is the missing angle? Well, add them all up, you get 470 degrees. So 540 minus your 470, the missing angle there is 70 degrees. So when solving any trigonometry problem, use this principle where you can. So where you can do this, fill all the angles in, that's what you do. So step 2 is to work out the sum of all the angles in the shape, and if we're using trigonometry it's normally triangle, and then you can fill in unknown angles. So that's step 2. Step 3, Pythagoras' theory. Now in mathematics, the Pythagoras theory is a relationship in geometry among the 3 sides of a right angled triangle. And in terms of area, it states, in any right angled triangle, the area of the square whose side is the hypotenuse, which is the side opposite the right angle, and it's the longest one, that's the area of that square is equal to the sum of the areas of the other 2 sides. This is trigonometry. A squared plus b squared is c squared, where c is always the hypotenuse. It's got to be the hypotenuse there, as you can see there. Let's have an example. If we've got this here, triangle, and it's 3 centimetres by 4 by 5, as you can see, you get 3 squared plus 4 squared equals the h squared, which is the hypotenuse, which is 9 plus 16 is 25. The square root of 25 is 5. So that one there will be 5. So therefore, in any right angled triangle, you can always apply this theory. You can always apply this theory.